Hello, fourth graders. This is Mrs. Nagy, and I am about to jump into math lesson 97, which is called Constructing Prisms. And as always, you can do the mental math and the problem solving, but we are not going to do that together during this home-based learning time. So, first of all, let me just say I really missed you guys. And we had a really good time. It was just a couple of us that showed up today for our math Zoom meeting. And that was pretty awesome, though. We really had a good time and got a lot of math done. So, in fact, those of us that showed up already have all the non-star problems done in math lesson 97. So I have been doing math for quite some time today, and I'm looking forward to jumping right in with you guys into this lesson. So now, if we were in the classroom, we would have some special papers that called nets, geometric nets. So if you take a quick look at page 640 in your book, there is a diagram, and it is a cereal box, basically, that is opened up, cut out to be opened up, and you will see it says about the middle of your book, it says, if we tape an empty cereal box closed and we cut it along 7 edges, we can flatten out the container as shown below. And we can look at the different, what you would call the front, the side, the top, the back, the bottom, and so on. And normally in the classroom, we would have the lesson activities, as you see on page 640 at the bottom, pages lesson activity 28, 29, and 30. We would take some scissors, some tape and glue, and we would take these shapes that we call nets, and we would fold and glue them together to make different types of prisms. But being at home and using a video is a little bit difficult to do that, so we're not going to get to do that now. However, if you want to play around with making a rectangular prism, feel free to cut up a cereal box, and you can follow along and do the questions 1 through 5 on page 640, and you can do the lesson practice problems. So feel free, if you want to play around with prisms and challenge yourself to make different types of prisms. I would love to hear how it went. I'd love for you to tell me about that, but we're not going to go deep into that because it would be really hard to do on a YouTube video. So what we are going to do is take some extra time today to go through all of the non-star problems, maybe at a slower pace, I'm not sure. We're going to shoot for about a 35-minute video, and if there's any extra time, we will do some non-star problems. But a lot of the problems today are a little bit more complicated, a little bit more challenging, so we'll just see where we get. So we're going to start today with our star problem number 3, and here is how I would attack it. Okay, it says Victor has $8. Dana has $2 less than Victor. How much money do they have altogether? All right, so if Victor has $8 and Dana has $2 less, which is $6, how much do they have altogether? Let's add those two, and we find that altogether they have $14. Okay, well that one wasn't complicated at all. Number 5 says 5/8 of the 40 students wore school colors. How many students wore school colors? Draw a picture to illustrate the problem. So there are 40 students total, and we want to know what 5/8 of 40 students are. So one way to do that, and it's the way that they've asked us to do that, is to make a diagram. So total we have 40 students. Of course, this is just one strategy, right? We could have written an equation. We could have tried to solve this problem by writing out the 3 lines of an equal groups problem. But what we are going to do is divide this into 8. So first of all, let's divide into 4 up here. 1, 2, 3, 4, and then make 4 equal shapes down here. It's for a total of 1, 2, 3, 4, 5, 6, 7, 8. And we want to know what 5 of these 8 are. So let's see, there's 1, 2, 3, 4, and 5. So 5/8 is this much, okay? And then 3/8 is the rest. Now the 5/8 part means the students that wore school colors. And this is, they did not wear school colors. Okay, so to find what each of these are, we have already divided it into 8 equal parts. Now we need to know what these 5 are. So let's say 5 divided by 8. Let's go ahead and do the computation, the math. We've already drawn it, but we want to know what each one is worth, each space. So we think 8 goes into 50 how many times? Since it does not go into 5. Okay, so let's see. 8 into 50. Let's just think out loud. Let's see. Is it 8? 8 times 8? 64. No. How about 8 times 5? What do you get? 40. So it's somewhere in between 8 times 5 and 8 times 8, right? What's 8 times 6? There we go, 48. In case you can't remember your multiples, if you can't remember this, just try a few things and get close. Or use your multiplication chart. 6 times 8 is 48. We subtract and we get 2. So that tells me we have, looks like, if we did this right, we have here 6 remainder 2. 6 remainder 2. Okay, let's see. Let me put a sticky note so I stop losing my place. Oh, I see a problem. I'm sure you found the problem already. What is the problem that I have here? It is that there's 40, not 50 students. 40 divided by 8. I just noticed that that should have been 40. Sorry. 5 times 8 is 40. And we get 0. So it's exactly 5, isn't it? Okay. So if each of these are 5 students, let me write that in. Okay, good thing I got back out of my little rabbit trail I seem to have gone on by writing the wrong number. It's very important that we keep looking and checking to see, are we using the numbers in our book? So, okay, so if each of these are now divided 5, 5, 5, and so on. What we need to know is what 5 of those 8 are, which means we're going to take 5 times the 5, and that's going to give us 25 students. So 5 out of these 8, 5, 10, 15, 20, 25. So it's this section here up until here. That is the part that represents 5/8. Okay, next let's go on to number 9, which says, Pavan has filled a pitcher with iced tea for 2 guests and himself. Okay, so there's a pitcher of iced tea and it is full. That's what I know so far. Let's keep reading. The capacity of the pitcher, and we've learned about capacity, that's how much liquid something can hold. So the capacity of the pitcher is 2 quarts. Okay, it's a 2-quart pitcher, got it. Next we see that it says, how many 10-ounce glasses of iced tea can be poured from the pitcher? Explain your answer. So for number 9, I like to start by drawing a picture of this. So here is my pitcher. Okay, maybe I'll have a handle and a little spout of some sort. And I know that this pitcher is 2 quarts. 2 quarts. Okay, now from another assignment, I hopefully remember that 1 quart is 32 fluid ounces. Okay, well, this is telling me there's 2 quarts, which means this is the same as 64 fluid ounces. All right, now the question is, how many little 10-ounce cups, 10 ounce, 10 ounce, 10 ounce. How many little 10-ounce cups can we fill using the amount of liquid in this pitcher? Okay, so what we can do is we can say, okay, so we have 64 divided by 10. Let's work that out over here. 64 divided by 10. Okay. And just right off the bat, we can say, okay, so 64 divided by 10, I know 10 goes into 64 6 times. Even though it's a 2-digit number, which we don't work with much, it would be easy to do it this way. 6 times 10 is 60, and we subtract and get 4, which means we have 6 remainder 4. Now this 6 remainder 4 is the same thing as 6 and 4 out of 10. So 6 and 4 tenths. How would we write 6 and 4 tenths? 6.4 glasses can be filled. And that is our answer. Now, since we were dividing 64 by 10, what we also could have said is we could have put a decimal point here, and since we were dividing, we could move by 10, a multiple of 10, we could have moved this back 1 space and gotten the same thing, 6 and 4 tenths, without even having to do all of the division. Okay, so again, if you're dividing by 10, you can put a decimal point at the end of the number, like 64, and move it back 1 space, 6.4. Okay, moving on from number 9, we get to number 10. And number 10 is kind of a fun problem in that we are asked which letter represents the number closest to 3.5. Okay. Again, this is number 10. And the question is, which letter is closest to 3.5? I'm just going to go ahead and write which letter. Which letter is it that's closest to that? Now, we have this long line. On one side, we have a 4. On the other side, we have a 3. Now, what I recommend that you do, and I've said this before, is when this gets a little bit hairy and you're not quite sure what to do, you could always turn this, just to think about it, you could turn it into money. What if this was $3 and $4? Because remember, adding zeros doesn't change what the worth is of a number. So 3, and then what if we turn this one to look like money as well? $3.50 would be right in the middle. So that means 3 5/10 is right smack in the middle. And the closest thing to that is the letter B. So which letter is it? It is B that is closest to 3.5, or 3 5/10. Okay. Number 11. Says Gretchen paid $20 for 5 identical bottles of fruit juice. She received $6 in change. What was the price of 1 bottle of juice? Okay, so for number 11, we want to think about, what does this problem say? First of all, I feel like this problem is a little bit tricky, because every time our book is saying somebody paid a certain amount, they mean that they handed over that much money, not that that's how much money they actually spent. Okay, so for number 11, I think we should think of it more like Gretchen gave a $20 bill. Okay, that's different than actually paying that much. Okay, so she gave a $20 bill to the cashier for 5 identical bottles of fruit juice. Okay, and she received $6 in change. So she got back her change. What she got back was $6. Okay, so then what did she actually spend? She spent $14. Okay, so this is one of those two-step problems. First of all, we need to find out what she actually spent. And we find that she spent $14, excuse me, not the $20 that it seems like we are going to be using. Now we know that she spent $14 total. Okay, so let's think about this equal groups problem and how we can set it up into our